All right. I guess, yeah, we are live now. Yes, I see people are excited for day two. Well, you should be because we are actually building agents today, and that will be really interesting and it's exciting. I get it. So let me quickly bring up my screen, okay? Okay, let me check with my audio once. Uh, is my voice clear? Can you all hear me? Can I have some feedback on my voice? Can you all hear me? Are my words clear? Whatever I'm speaking, is it being delivered correctly? Can we proceed with this voice? Okay. Yeah. So people have given the feedback. It's positive. All right. So I think this should do. Fair enough. Now, let us start off our day two with understanding what we are planning to do right now. Okay. So the very first goal here is that we will quickly look into what Ollama as a service is and how we can install it. Then we will go to OpenAI SDKs. We will see how we can uh, use them to build agents. Okay. So let me quickly just share my entire screen for that purpose. Just go back and I'll. Okay. Somehow I'm not able to share my entire screen. So for now, let me try to share a window probably. Let me check. Okay. Just give me a minute, students. Let me see why I'm not able to share my entire screen. Okay, I think I'll be able to share this screen for now. Let me bring up my screen. Okay, can I have a quick feedback? Can you all see my screen? Let it come up. No, right? Okay. Let me try to reshare my screen. Let's see now. Yeah. Okay. I think by now you all should have my screen visible. Let me just confirm. Okay, we have VS Code opening. Cool. We have the browser opening. All good. All right. Good evening, all of you. So let us start off firstly looking into Ollama.com. Okay. So O followed by Llama.com is again a service that you can download locally. It is available for all major platforms, which are Mac OS, Windows, and Linux. Simply you have to click download. You can select your operating system and just simply proceed with this download for Windows. Okay. So suppose if I click on download for Windows, it will start off with this executable, which is 700 MB. Depending upon your internet speed, you might be able to quickly download it. Okay. And similarly, Linux people can simply follow this curl command. You simply have to make sure that you are doing with the admin permission. Just do sudo and install this to it. Okay. Whereas for Mac OS, remember that it requires Monterey as Mac OS 12 or later version to run Ollama. Okay. But I think majority of the MacBooks, like even 3 or 4 year olders, should be able to support this with Mac OS. So this is Fairly simple. The installation is fairly simple. When you are done with the installation, you simply have to proceed with the next, and how to confirm whether Ollama is installed or not. So what you'll have to do is you'll have to start up your PowerShell. And you'll have to type Ollama, okay? Or you can also type Ollama dash dash version, okay? So this should give you the idea that Ollama is installed or not, okay? So Ollama is a service which you can use over the terminal. So even if I just say Ollama list, so this should be able to give me all the local large language models that I have with me available offline, okay, which are like downloaded on my computer itself. So if you are running on, say, a non-GPU machine, that is also fine. Ollama will be able to run it. Make sure that you have good amount of RAM. To run this type of programs, it is recommended that you have at least 16 and 32 is recommended to have 32 GB of RAM at least. Now, when we are on Ollama, what you can do is you can go to models. On models, you'll be able to realize that there are many such models available right over here, right? So one thing that we have to make sure that when we are building agentic flow, or we are building AI agents, we need to make sure that our whatever thing that we are downloading, they are compatible with tools. Okay, so there's also filter on top of it, embedding vision tools. So we're looking for models which are compatible with tools. I'll just select it, and you can see DeepSeek has certain models. Quen is again open source models. Llama 1, Llama 3, Llama 3.1, 3.2. Mistral is again a powerful model. Quen is again powerful model coming from China. And Quen Coder is good for when you're building code generation type of things. So you can download any of these models which are compatible with your system, right? If you remember AXPL system RAM compute LLM. So if you remember, APXML is something which I referred to yesterday. This is a website that you can run for now. Gemini API, is it okay for now? Well, yes, you will have to just change your wrapper a little bit. Uh, so that's around it. OpenAI SDK will support any of the open source or LLM. I'll in fact explain you how you can use some of them, right? So first of all, what we have to do is, I think we can just go to this VRAM calculator. Let me open it. And this is the one, AP tools slash VRAM calculator. Right over here, we don't need to fine tune. We just need to do inference. On inference, we can check the model. So for an example, Llama 3.1, 8 billion, okay? I'll just simply type out over here, Llama 3.1, I select 8 billion model. I just need to ensure if I can run it or not. Of course, I will not be running it on full precision. What does this mean is that, let me click on this model on Ollama, okay? You will realize that there are different versions of it if you go on view all, okay, in models. So there's also a model with full Llama 3.18 billion full precision, but we don't need it, okay? So we will be going for a smaller version. Let me search Control F8B, okay? So you will see these are all 8B models with different sizes, 4.9 GB, which is by default, Instruct 2.0, and these are different quantization levels of the models, right? So even if we go for something as big as full precision FP16, okay? So this is what is mentioned over here, FP16 in the APXL VRAM calculator, right? So what we will do is we will simply stick to a smaller size of the model. For an example, Llama 8 billion by default, which is 4.9 GB. This comes by default with, you can say, Q4 quantization, okay? So we will select it. So this is what we will be running, right? In order to run this, you will realize that you need at least 6 GB of RAM to run it, okay? If you're running it on any GPU or any VRAM, this is the calculation that you might need, okay? So you can also select your GPU if you want from here for better understanding whether you will be able to run it or not, okay? And the rest of the things, you need not change it a lot. I think you just need to put your model right over here. Okay, select the quantization value to QK, Q4KM. Again, this is how we quantize things. And if it is under 6 GB, I think people who have 16 or 32 GB RAM, 16 GB RAM also should be able to run it. Okay, speed will be a little different because we are computing for 3060 GPU. We will not be using any hardware acceleration. Okay, so that's point number one. So after this, I think we can then think of considering any of the model right from right over here, right? I'm still downloading it because my internet speed is not good. But let me check if I have Ollama installations with me. I might have downloaded this setup at some point. Okay, I think this is Ollama setup. Let me run it. Double click. Okay, it might take some time. I'll just skip the installation part. It is very straightforward. As soon as you download this executable, just try to run it. And the only the installation is anyways come up. Okay, so this is how you will get. Just a second. This is how you will get the window on which you can click on install. You can click on install. If you click, it will proceed. I'll just cancel it for now because I have installation with me. Okay, so I'll just click I'll just click on cancel and I'll say exit. But you guys can just click on next, and the installation will finish for you. So once you have finished this installation, the next part is to understand which large language model you will use, right? I told you you can start off with Llama 3.1 version, or you can go for even different models, but make sure they are with tools. This is completely up to you, people. You can experiment wherever you want. So even so, for example, even Gamma 3. If I click on tools, I think Gamma 3 doesn't support it. So we'll find over here there are many of them. Okay. So if I have to work with any of it, say I have to work with Quen 3 for an example, I just need to run this command, Ollama run Quen 3. Okay. So let me open up the terminal. Okay. Ollama run, let me say for now, I'll just quickly run the Llama 3.1. Okay. You see, I was downloading this. Just need to run this. If at all we do not have this model, the Ollama will by default try to install it first. Okay, this command will run an installation, and installation will take some time, people. Okay, installation will take time because it is 5.8 GB of model. If you see 5 GB of model over here. Now, are there any questions? How do we select models? Okay, so selecting models completely up to you. Depends on what use case you are solving. In fact, if you go over here on Ollama, you will find some description of the model over here, right? For example, Quen 3 is the latest generation of LLMs, and it is used for mix of experts. So if you want it, Ollama 3.1 is new state of the art from Meta. You can read what Llama is good at, what Quen is good at. I told you Quen 2.5 coder is good at coding problems. Similarly, Llama is good for text generation. DeepSeek could be more better at thinking module, right? So depending upon your use case, you can select the type of tech you want to work with. Okay. Let me just quickly check if my voice is not breaking because I think my video was stuck in between. Right. All right. Soham is asking if I can just quickly explain tools section once again. So for the tools section, the idea is that we have different functions. Whenever we do certain type of coding, we create functions, right? So if we provide these functions to our large language models, they are known as tools. Okay. I'll give an example. For example, if I go to Gemini over here, okay. So say Gemini is a large language model. I say, hi Gemini, how are you? Okay, if I explain it, it will do the text generation. It is good at it. Okay. If I ask it, can you book a flight for tomorrow at 10 a.m. from, I'll say, Mumbai to Delhi for one person under my name. Okay. If I ask this question, let's see what kind of response will Gemini provide me. Okay. I can search for flights, but I cannot book for them for your username because I don't have access for this thing. Okay. So the idea is that large language models by default can understand the natural language, but in order to make them more capable, in order to help them do operations, we provide them with tools. Okay, and tools are nothing but functions that we write. Okay, it could be as simple tool as even to do calculation. Okay, I can define calculator with add, subtract, minus, and I can tell my LLM or my agent that if someone asks you to do this task, if someone asks you to book a flight ticket, then I have a function which does it. So you just take these parameters and hit this function. So that's what tool calling is all about. Okay. I hope that explains you. All right. I see people coming up with new questions. No, all good, right? Yes, kind of APIs. So I am creating a chatbot for major project. Can I do this with Ollama? But definitely, Ollama would be a good use case for you because you being a student, it is much convenient to go for open source things than going for a paid version. Ollama would be much more sufficient for you. You can download any of these models which are compatible on your local machine and start off from there. Okay. So, for example, if I'm running Ollama run 3.18 billion locally, I can just ask, hi, how are you? And you will realize that this large language model is completely running on my machine. It is not running on any internet. Even if I close down the internet, this Ollama is completely local on my machine. Okay. Can you book a flight for me? Okay. So you will see that the model is not able to book flight for us. Okay. Uh, can you share a email? Okay, to I'll say @gmail.com. And okay, I'm not capable of sending emails. Okay, however, I can provide you a template if you want. You will realize that these models are just good at communicating things, but they are not good at tools, which is where the agents, not even agents, the tool calling comes into picture, right? Agents are more about having the memory layer, the thinking layer, the decision making layer, the autonomous feature, okay, and talking to each other like agent to agent communication, agent to tools communication, and so on, right? So let us understand the idea of today. What are we trying to build? Okay, so for that, I think I have set the premise. What you will need is, so even if I start off this terminal, uh, are you people aware of UV? If you do UV dash dash version, this is a cool way to create virtual environments now. Previously, we relied on pip, okay? So even if you want to use pip, that's fine. You just need to do pip uh, python dash make venv.venv. This is the command to make virtual environments. Whereas if you are using UV, you can just simply say UV venv, and UV will by default use Python 3.29 for now, depending on the version. And it has created a virtual environment, which on Windows I can activate with .venv/scripts. For Ubuntu and Mac people, it will be bin over here. But for Windows, it is scripts and activate. You should be able to activate it. Okay. Now, with this, let me just clear screen and let me do pip freeze. And if it is giving me a lot of things, it will be because, yes, if it is giving me a lot of things in the version, it's coming from a global version. What I'll have to do is on my Python interpreter right over here, I have to make sure that I'm using the correct environment. So my interpreter has to be set on .benv scripts, and now if I do pip freeze, okay, it's still hitting from global, but that's fine. I'll just close it and restart. That should be fine with us. Okay. Yes. So now the virtual environment is activated, and we have a complete fresh set of code over here. Just make sure that Ollama dash dash version, your Ollama is set correctly, and Ollama list, you have at least one. See, I have experimented over time with different LLMs, hence I have so many of them. But you will need just one of it. I recommend to go with Llama 3.18 billion. That is fair enough. But if I just quickly cross verify for you some of the tool calling which are pretty small enough. For example, uh, if we go for Quen 3, which is also a one Quen 3.4 billion is a smaller model, and parameters, quantization. license parameters. Okay, but I'll recommend to at least go with 8 billion. The reason for that being because uh, you will realize that smart models they hallucinate a lot while choosing between tools. So at least 8 billion model is decent enough to do something like building an agent. Okay, that's needed. Any questions? Can I run LLM without GPU and VRAM? Yes, yes, Yuvadeep. You will be able to run it on RAM and CPU, but you need good amount of RAM. 16 or 32 is recommended. Live, basically, we are deploying agents on edge devices. Uh, yeah, something like that. How model agents are different from each other. Again, I'll explain that models are just language models. They are only able to understand our language, but they have no control over thinking, decision making, autonomous behavior, or interacting with the environment, or interacting with other tools, things like that, right? Agents are given this control over that, right? So let us understand quickly what type of agents are we talking about, okay? So there are many different things. For an example, if I say crew AI, okay, if I go for uh, lang graph, okay, so you will realize LangGraph is an open source AI framework. LangGraph is an open source AI framework designed by Langchain company. Okay, it is designed to build, manage, and deploy generative AI workflows, especially AI agents. Okay, that's where LangGraph is useful at. And to start with LangGraph, you just simply need to do pip installs, and it is a very powerful tool. I will say, really interesting. Uh, and I do like LangGraph. It's not like I don't like it, but I have a certain bias towards OpenAI SDK. I'll tell you why about it quickly. Then we have CrewAI. CrewAI is again a leading platform where you can do the task of building agents. Okay, you can quickly build them. Again, it has an open source environment. Then there are certain no code, low code platforms like N8N. So N8N can also quickly help you build agentic workflows on the go, okay, without writing much of the code. Then we have data stacks, Langflow. This is also one tool that you can keep in your uh, you can say arsenal to just have a look at it. It is also quite compatible with building agents quickly. Okay, so my internet is really poor today. I hope my voice is not breaking because my websites somehow are not loading, and unfortunately these hiccups do come up at crucial time, right? My internet was running fine throughout the entire day, and right over here I see there's a lot of lag. All right. Is there a strong demand for agent engineers in companies and startups currently, or is it more of a future trend? Well, I will say the demand is now. The demand is here. There's a very strong demand in the market for agent engineers. Okay, and it is much more needed that these agent engineers have thorough knowledge of how to build an transformer model, and you can say GPT model. They should know it, how to fine tune it, how to train it. Okay, these things are pretty much needed. So, okay. So if we talk about these platforms, let me just quickly skip the burden of loading these websites for now. I just wanted to give you certain ideas of different websites. Okay. Now, once we are done with this, let us talk about one product that we are going to use today, that is OpenAI Agent SDK. Although it might sound that OpenAI is a closed company, but OpenAI Agent SDK is not closed or limited to just OpenAI models. Okay, see, this is the beauty of this OpenAI Agents SDK, is that we can use any other model. We can also use Gemini with it. Okay, we can use any other model that we want, be it closed, be it open. Okay, we can support any type of model with this SDK. And see, this is an SDK which enables you to build agentic AI apps. It is lightweight, which is why I prefer it. It is easy to use. The commands are very straightforward. Very few abstractions are needed, so that's where it shines out. It's a production ready upgrade version. Okay, and this SDK has a very small set of things like it comes with built-in agents. It comes off with handoff, guardrails, and sessions. Let me just quickly explain you what this terms are all about, right? The agent, we know what it is. Agent is something that can drive decisions with autonomous behavior. It can think on its own. It can do complex tasks, okay? Achieve complex tasks by breaking down into simpler logics and following that logics with this own thinking logic, right? So that's one. But what is handoffs? So handoffs are when an agent gives the complete control of solving the problem to another agent, okay? So for an example, I will give you one example. See, I told you that we could have an agent with writes front end code. We could have an agent that writes back end code. We could have an agent that writes say maybe ML related, machine learning related code, right? And then we have a master agent. So what will happen is master agent is also good at communicating with the end user, okay? And as soon as the master agent realizes that certain task is very well suited for front end agent, and why not we just completely give the complete control to the front end agent? That's known as handoff. So what's the difference between handoff and tool calling or agent calling is that suppose if a master agent is calling the other agent to do something, it means that the control is still with the master agent. The other agent will just do the task, give back the response to the current agent with the control, and the agent with the control is the master of that particular you can say instance. Whatever is being running, whoever has the control, if it is calling a function, if it's calling another agent, it retains the control, right? But if we have to do a handoff would mean that the current agent is completely giving the control to the other agent now, and the other agent will be responsible now to communicate with the end users and other functions or other agents in the network. So handoff is when you completely give away the responsibility of that task to some other function or other program, so that now that other function will be responsible to completely end that responsibility. Okay, so that's there. Guardrails are again very much useful when as a feature to do certain security check layers. Okay, for an example, suppose if we do not want our function to respond back in numbers which are in floats, for an example, we only want to give back whole numbers or integers only. Okay, so we can create a guardrail which only comes. See, I'll tell you where guardrails can be fit. There are only two places where you can fit guardrails. One, before you start the task with the agent, that is during the input, or second is during the output. You cannot put a guardrail in between this process. Dekho, the layers could be input layer, then agents working with different agents. Now things could go back and forth over here, different tool callings. You cannot put guardrails in this network because this is more like a black box. We will not know what type of decisions or path the agent will choose to complete this task. We will rely on the agent to do whatever it wants. Agent has the complete control. Maybe the agent wants to call this function or not, the agent wants to call another agent or not. This is completely their decision. So at the end, before we send back the output, this is also a place where you can have a guardrail. So we can put a guardrail over here that if the output is in floats, we raise the error flag and we say something went wrong, or whatever we do, we put it as a warning symbol and we do not let this output pass to the end user. Okay, so there are many different guardrails that we can put in to make our agent more restrictive and more fail proof. Okay, so that it doesn't go off the rails and do something crazy around, right? Because we want our agent to be more professional and more safe to use. So that's the concept. And then again, sessions are about one run. Okay, so run is nothing but when you start the input and you get the output. This is one run. So during the input, during one run, we could maintain sessions like conversations happening, and then there could be something like also tracing. Tracing is also a very good feature, but tracing is somehow not available from OpenAI to models which are not by OpenAI. Okay, so there are other workarounds. Suppose if you want to use open source models and still do tracing, then rather than using OpenAI SDK's tracing support, which is only for their own proprietary models, we could use something which is more open source. Okay, and we can use any of the tracing tool which can help us trace. Or tracing is nothing but logging your things, right? What agent did, we could see from each trace, the complete trace, what agent did from where to where and how and when. Okay, let me try to open up the OpenAI, which is my paid account. Let me see if I have few traces which I can show you. Okay, I'll have to do it off the screen because I'll have to enter the password. But again, the internet is not working great for me. I'm not able to open this website. I'm not sure if the chat is even live. Let me just refresh my browser, the YouTube live. Come on, people, can I quickly have some chat? Is my voice clear? Can you all hear me correctly? Yes. Uh, can I modify or tune Ollama models to make specific models like I need a chatbot related to agriculture background? Yes, Shiva, and in fact, that's where fine tuning will come into picture. You can fine tune your own model based on your data, which will be much more well suited for your domain. AI agents come in which role, like LLM engineer or AI engineer? I think AI engineer is the bigger picture. LLM engineer is a subset of AI engineer. So AI engineer should also understand agents. So does LLM engineer. LLM engineer more specifically looks into the NLP part, whereas AI engineer can also talk about different things like computer vision applications also, or vision language models also. Whereas LLM is all about textual response. Okay, so that's it. Yes, I think you all are able to hear my voice clearly. That's fair enough. Okay, cool. I think let me see if all right. Okay, no. So currently I have set off my APIs. I cannot show you that. But again, that's not a big deal. You can just simply go on tracing and see how things are working if you will be using OpenAI as your service. Okay. But I recommend to not waste money on OpenAI for now until unless open source versions are available with us. So, well, that's about a little bit about this tool that we're going to use. Now, in order to use it, you will have to do pip install OpenAI agents. Okay, so I'll just quickly do this for us. I'll do ub pip install OpenAI agents, and we'll quickly install whatever is needed to run this tool. Okay, and so this is an example how we can use it. From agent, we'll import agent. Runner is nothing but runner is the instance or the class which has a function run sync, which runs things, right? It takes agent as the input, the user query, and final output is where you will be able to see the output coming from this example. So you just need to make sure that you have OpenAI key to run it by this. But I'll show you how you can run it without OpenAI key also. Okay. So that's about agents. If you look at the documentation, I recommend that you go through documentation a lot. Okay. So agents are ready-made code that you can simply use. You just simply need to say from agent import agents. Okay. And maybe you have a function or a tool like get weather. Okay. Which returns the weather. You can design an agent right over here. See how the agent is being designed. Agent. What is the name of this agent? So you can call this agent something. We also name our pets. We give our pets names, right? So similarly, we can give our agents names. So this is the haiku agent. Instruction always respond in haiku format. What type of model we are using? Here we will not be passing OpenAI model. We will be passing our own open source model. And what type of tools you have? So tools is always an array. Here we have only one single tool, hence an array of single function name, which is get weather. So this is the function name that is needed. Okay, once you have this, uh, you need to pass some context so that agents will understand what it has to do. Again, I told you, Pydantic is a type of class in which we defined things like name, date, participants, and things like that. Okay, this is the format which we use to define things for agents, and we put it over here, and that's where the agents come into picture, right? So as easy as this is very easy. If you go through the documentation of OpenAI SDKs, you will realize that you can quickly start off building your own agents. How do you run your agents? So runner is the command. Runner.run will run an asynchronous call. Runner.sync will run a synchronous call. So I'll again skip this part, that what is synchronous versus asynchronous programming. You can quickly get it done. I think it will take 90 minutes of your efforts to learn what is asynchronous programming, and you can quickly understand what is happening between what is the difference between run and run sync. Okay, but for now, dot run is what we will be using, and dot run will help us run a function. again. So what are sessions? So okay, let me see. Is my voice coming up fair enough? Let me see if I can just switch between my Wi-Fi. Okay, all right. Cool. So agents, they provide built-in memory also. I told you that agents have their own memory. They maintain their conversation history across multiple runs and they handle everything. So session management is something that you can do with session management right over here. Okay. Session is the SQLite session, create a session ID and you can learn how these things work. How it works is before each run, the runner automatically retrieves the conversation, and after each run, the runner automatically stores what type of memory it has to maintain, and the context is always preserved. So there are different memory operations which are useful, uh, which you can see. You can either run with no memory, you can run with SQLite memory, you can run memory across multiple sessions, and so on. Okay. So that's the idea. And finally, last but not the least, results are something which is useful to give the output back to us. So final output is the proprietary name that OpenAI will use from where we can get our final output. Okay. Again, I'll also help you demonstrate how you can use it. Even if you go for intro, you will realize that here is result.final output. This is how we get output from the OpenAI SDK. Runner.run sync or runner.run simply.run will also do the same thing. Runner.run, you just need to pass the agent which you want to use and the query which you want the agent to complete. Before that, to declare an agent, you need to use this class agent, which follows name and instruction by default, which is needed. And this is a little bit about how we can build on top of it. Okay. So now let me start off with giving you some basic imports. Okay. So we will simply start off with importing OS, and async.io is again the Python library which helps us run asynchronously the input output functions. Uh, env.loadenv will be useful when we have to load some API keys. For example, we can create .env file over here in the same directory where we will be running it. For example, if we are storing OpenAI API key, something over here, so we can just do some, for example, this could be an example key, okay, that we can use. So you can just save it and you can use load env to load this value from here. This will safely load the value without exposing your APIs. This is a good way. As a good developer, you should always store sensitive information or private information in .env like this with a variable name followed by a string. It need not be a string. It will by default also take it as a string, but you can maintain it to take it like that. Okay. Now, what are we running over here is from agents. You already know that we can use agent runner. We won't need trace because we are not using OpenAI model. A function tool will be used for tool calling. Since we are not using trace, we will be using set tracing disabled. What it will do is, if you try to use this OpenAI SDK without OpenAI models, it will every time in the as a warning print on your terminal that tracing is not set, tracing is not set. So we don't want our terminal to have that warnings, and we will simply say tracings are disabled equal to true. We will just run it once. And OpenAI chat complete model. This is something that we will be using to wrap our open source model into this SDK. That's all about it. Okay. But again, OpenAI response will be useful to handle the response type, the response events, and async OpenIO is again used to do asynchronous programming. And from typing dict, I don't think we will be using the dict version from typing. Let me quickly close off the terminal. Let me quickly close this window. Let me zoom in a little bit. Let us see if things are clear till now. People, you are following everything fine till now? I'll give you this code by the way. So all the people who will be coming in tomorrow, I'll give you this complete code so that you can run it off. And tomorrow we will be doing yet more than just building agents. So the idea is that by the end of this class, we will completely build an agent workflow. You will be able to even do autonomous behaviors like send email to anyone you want. Okay, that will be available. As a homework, right, today itself, you will be able to take an idea how you can build agents which can book flight tickets or do other things for you. But tomorrow will be more interesting. Can you also provide the PPT? I'll try that. I did try. I'll have to take screenshots and save it somewhere. So, which is why I mentioned that Friday is a weekend. I'll try to take screenshots today evening. So all the people who will come tomorrow, they will also get PPT from me also. I'll give you the PPT. I'll give you all the source code. And day three is more than agents. Agents we are covering today. Day three will be how we can use guardrails, how we can use more different things, how we can do maybe complete transfer. We see what handshake would be, or completely giving other responsibilities right over here, right? So that's what we will be doing, the hands up. Okay, so with that being said, all right, all good till now. The chats are coming in. Let us look at the part one. The part one is to set up Ollama and certain custom tools. So load env, again I told you, this is the command used to import any API keys or any things that are sensitive. You do not want to write it in the code, and you can simply use it. So for an example, we could have used this to load OpenAI key if you were doing it. But since now we are not doing it, we won't need it. Okay. All right. So override equals to true. What does this do is, so sometime for Windows people, it could happen in other OS also, but especially for Windows people, what I've realized is that Windows somehow uses different cache. Okay. So suppose if I do any changes, for an example, as a developer, I'm developing right now, and I went to .env. I changed something like this is vr. I write g and I save it, and then I try to run this code again. It will not run with the latest value. So override equals to true will make sure that we are forcing the env to load again from the .env file. Okay, that's the idea. Again, I told you to disable tracing, to suppress that warning, we simply need to say set tracing disabled equals to true. You can just simply hide this code to see what I mean by that. Okay, and tracing is something that is useful to see what your agents are doing. You can also do it open source also. Okay, there are different tools that you can use for it. Again, not our purpose at this point. Now, Ollama's API, what we are going to do is I have Llama 3.18 billion with me. I told you you could have anything for now. See, the only thing is when we are creating an Ollama client, we need to use async OpenAI. Okay, so I told you we will be using this to generate our open source client. And on line number 4, you see OpenAI chat completion model. We'll be using it to pass chat completion with our open source model. So this is how you can declare your open source model right over here. And again, I will repeat people, in order to run this, you need to make sure that uh, you have Ollama list, at least one name coming up over here, compatible name. For an example, if I try to use Gamma 3, which is 1 billion model, or even Gamma 3 4 billion model, I'll get an error if I try to run this, because these models are not compatible with tool callings. Okay, so I repeat, make sure that you have a correct large language model, something like Llama 3.18 billion, or even Quen 3. Not even Quen 1.7 billion. DeepSeek would work 8 billion, or Quen 7 billion model will work. Anything which is 7 or 8 billion should by default support tool calling. So make sure you have something like that. It will take up 4 or 5 GB of download. Once you have it with you, only then you are compatible to run over here. So by default, the Ollama is by default running on port number 11434. That's the default port number for Ollama. So that's what we have written over here. Okay. All right. Hi, Madan, coming in from Nepal. So we have an international person with us. That's interesting. So, all right. Now, once we are done with that, what's the next idea? The next idea is simply to create the chat model. So we will create the model instance for our agent to use, which is, remember, Ollama model. Okay. By this time, remember people, by this time we have not declared any agent at this point. If you remember, we imported agent, but it is not being used at this point. So remember, whatever we have done till now, it is only declaring a large language model. Okay, our LLM is in place now. And what is the name of the model? it is 3.18 billion model, and the OpenAI client which we are using is the Ollama client. Okay, so this is the difference which will come when we have to run between an open source model using OpenAI SDK. So if you follow my steps correctly, you will have no problem at all. All the libraries are as per the current version. If you're following this live and you have Ollama installed, you are following how I created a virtual environment, you are good to go. Okay. Are we creating and deploying our virtual environment? Yes, we will be using virtual environment, which I have created VENV. Again, one repetition for that would be if you're planning to use UV, you simply need to use UV VENV. When this command virtual environment is created, or else you can use Python dash make venv dot venv with the environment name, and virtual environment will be available. In order to activate it, you simply need to type dot venv scripts and activate. Doing this, you will see virtual environment is activated. In fact, like if you have something like this on the terminal, this means that the virtual environment is activated. You see, this is the LU live class is written over here. Let me do deactivate, and let me now do okay, let me now do dot venv scripts activate. You see, I have my virtual environment activated, which is right over here. All right, so this is the idea. Okay, now again, does the model get executed dynamically while running, or do we need to install it manually? uh, if you run the command Ollama run with the model name, the model is by default installed. Okay, if you so what is the difference between Ollama run and Ollama pull? I'll tell you. So when you say Ollama run the model name, it dynamically installs the model if it is not available, and on successful installation of the model, it directly starts the chat terminal. Okay, it's able to chat with it. Suppose if we only want to install it, we do not want to start the chat, then rather than using Ollama run, you need to use Ollama pull. So Ollama pull model name will install the model, and that's it. Ollama run with the model name will check if the model is available offline. If not, it will go to the internet, install it. After installation, its task is not over. It will do a third activity, which is to start the chat terminal. That's the difference. Okay. So both the commands are okay. You can do Ollama pull model name, Ollama run model name. It will automatically install the model at your local place. So, but using Ollama local, it will make inferencing slow, right? Yes, definitely it will make inferencing slow. And in order to make it faster, you can use OpenAI's paid API. You can use Gemini. You can use any other LLM provider online. You can use maybe Azure instances where you can find all the large language models running on cloud. So that's completely your choice. In order to keep it more generic and to keep it available to everyone who cannot afford OpenAI API keys, I prefer to demonstrate it with the local installations because anyone who doesn't have 5 10 $15 or they do not want to waste that, they can simply use this tutorial offline. Okay, that's the only reason. Cool. I think that makes sense to all of you. Now with that being said, OpenAI chat completion, this is how you declare the model. We are good to go till here, right? All right. Now see, what is the agenda, what are we doing today, right? See, our primary goal is nothing but to demonstrate how we can create different you can say uh, agents which can do a lot of different things for us. Okay, so for example, suppose we need to write emails, for an example. Let us say we are working in for a marketing domain. Okay, so marketing domain mein kya hai, we have to write cold mails. Any one of you, if you understand how sales work, so these sales people, what they have to do is they have to write a lot of cold emails. Like they just take up hundreds of potential people they can target. You see how these people sell you credit cards, just simply call people. So sales people also simply write emails, and anyone who replies, that's how you get a sale. Okay, so let us see what is the idea. So the idea is that we will be creating agents which can write different type of sales emails. We will do different persona for these people. We will see that how we can create three different peoples with different persona to write mails, and then work around with it, right? So we will try to look into all these things, how we can come it up so with it, right? So the very first thing that we need to do is we need to define our function. So without wasting further time, let us quickly look into what we are doing right over here. I'll close this terminals, okay, and I'll define that we are using a function over here. So the only difference between defining a tool for large language model is you need to use @function tool. And if you scroll up, you will realize that we are importing it from OpenAI SDK. Okay, so OpenAI SDK has a method known as function tool. And how do you use it? You use it as a decorator @function tool above any function. So above any function, if you put @function tool, it explains the OpenAI that this is a function that can be used by you for any task. What is the name of the function? Save email to file. Okay. Now, what is the goal of this function? The goal of this function is to mimic an autonomous activity. Ideally, what you will have to do is in this code, you will have to replace the logic of not saving the file to your local system locally, but to actually sending that file using some API keys and using some APIs, such as any email API that you can use. You can use Microsoft API, you can use the Google API for Gmail or for Outlook and any other email provider. Okay, you can try to see and check how you will be able to do it, but that's not the part of the goal. We are not learning how to work with Microsoft or Gmail APIs, but the goal is to do something which is autonomous. For now, we are saving the emails locally, and we will save it with the file name right over here. Okay. Yes, Sahil, you will be able to get this code. I will be giving this code to all of you in the tomorrow session. Okay, I'll put it everything in the drive and I'll give you the link tomorrow. So I think this is clear to everyone. We should not waste much time in understanding what this function does. It is a very simple function. It uses an open command with the right say command, and it simply puts in the email into it and stores it. Okay, that's the idea around it. Now let us define personas for our agents. So in order to define personas, we will create three different agents. Okay, so to create three different agents, we will write free text. See, this is like, creating an avatar with free language. What I'm mentioning over here is you are a sales agent working for, say, any company name, okay? A company that provides SAS tools for ensuring SO2 compliance and preparing for audits, okay? You can write whatever you want. You are a sales agent working for XYZ company. This company has XY LMNO product, okay? This product is used for this and that. So you write professional, serious, cold emails, okay? So this is one persona. If you look at this instruction number 2, you write witty, engaging cold emails that are likely to get response. Third, you write concise, to the point cold emails. You see, we are using three different personalities to do work. So even as humans, even as persons, uh, if we have three different developers, if we have three different content writers, three different actors, we all come with our own personality, right? Someone is more witty, someone is more engaging, someone is more concise, someone is more professional. So we have created three different personalities just to make sure that we get uh, different variations in creating agents. Okay, now if you remember when I explained you right over here, if we go to OpenAI SDK, how to declare agents. So declaring agent, it is as simple as using from agents import agent and using this agent class, passing in the name and the instruction to it, right? So right now we have instructions right over here, instruction 1, instruction 2, instruction 3, right? We just simply need to give them names and put it into that class, okay? So see, how do we instantiate agents? So this is my sales agent 1. Its name is professional sales agent. Second person is engaging sales agent. Third person is busy sales agent, okay? Because it writes more concise, to the point emails. And what are the instructions? Instructions are 1, 2, 3, and so on. If you realize from the documentation, we are adding one more thing. In the documentation, there were only two parameters passed, which is name and instruction. Here we are passing third parameter known as model equals to Ollama model. And why is that so? Because we are not using by default OpenAI models. So if you are using OpenAI models, you can just set it up once on the top, uh, and you can skip this third parameter. But if you're using any parameter, any model which is not from OpenAI, so this is the beauty of this framework. Okay, why I like OpenAI agents SDK to make agents is because it is compatible with any of my agent. Okay, whichever agent I want. Oh, sorry, which of the LLM I want, I can use it right over here, and I can make it completely open source also. So that's completely up to us. So we are doing it in this program also. We are using Llama 3.1 right over here, right? So I have created three different agents right now, right? So yes, so that's the idea, and it's as simple as that. Now, if you understand what asynchronous programming does for us, is asynchronous programming is nothing but something that helps us run instructions, run codes in parallel. Okay, it kinds of mimics something like multi-threading and multiprocessing. It's kind of built on top of that. Okay, built on top of that logic, asynchronous programming. So let us run agents in parallel. So I have created a asynchronous function. So async. So how do you create async functions? So simply on the top, if you see, we have imported async IO, right? This library, line number 2. And once you import it, Python will automatically start reading this as a reserved keyword, which means that this particular function def, this is the format of Python to declare a function followed by a function name. If you write async in front of it, it will realize that I can run this function asynchronously. And asynchronous.gather, what it does is it runs all the agents in parallel. Okay, sales agent 1, sales agent 2, sales agent 3. It will not wait for sales agent 1 to complete execution. It will give away the command. It will give away the command to agent 2 and agent 3. And by using parallel compute power, we will be able to generate results from all these three agents in together. Okay, that's the idea of asynchronous. And outputs will be result.final output for result and results. So if you see, results will contain results from three different agents in parallel. And what is this doc string? So doc string is always useful when we have to explain what this function is all about. And in message, write a cold sales email. Okay. And if you remember what our agents are like, let me open one agent. You will realize that our agent has a name and instruction. And in order to run an agent, what do we need to do? We need to use runner.run. Remember what runner.run is? Runner.run is the OpenAI's way to run something with an agent. And what does it take? It takes the what agent do you want to use and what is the input for that agent. We are passing sales agent 1 with the message. Message is what? Write a cold sales email. Okay, so that's the message. And all these three agents will do their task automatically, right? If you see, where is the program, where is the code? So this is the power of agents. We don't need to give that. Large language models will handle the natural language processing, and agents will take up the complete responsibility to make sure that the email is written. Okay, can you explain the workflow of this program in brief? Again, that will be way too time consuming. So for now, if we had a- at least 30 more minutes in buffer, I would have done it. Okay. But you can just rewind this video and completely take it off whenever you want. Rewind as many as times you want. You will be able to run this complete flow. Okay. So this is the idea of run parallel agents. But what I can do is, Soham, and for everyone else, I can just quickly give you a review what we have done. See, part one, we imported certain libraries, okay? We loaded an environment which is not needed for us. We can simply delete this part. Set trace disabled. What is this doing? This is doing nothing but it will skip some warnings in terminal output, okay? What is Ollama client? Ollama client, we are setting up Ollama as our service provider, okay? And with that, we are defining Ollama model. What is Ollama model? Ollama model is what type of model we are using. You can define the model name right over here. Okay, so that's one. And then we are defining a tool. What's our tool? Our tool is to save email to a local file. Okay, so this tool does nothing but saves an email in local machine for now. This is where you can make it more interesting by adding a function here to actually send the email. Then The next part, what we're doing is we're defining different personas for our agents, which is nothing but a prompt. Okay, we are putting prompt to explain what this agent is all about. You're a sales agent and you do what? You write professional emails. What is second persona? You write witty emails. Third is you write concise and to the point emails. Okay. After we declared instructions, we created different agents. And how do we create agents? We use OpenAI commands to do it. We put the name, we put these instructions, and what model we are using right over here. Once this is done, we are using a run parallel agent function to run all these three agents in parallel by using runner.run in async.io.gather method. Okay, so this is what async IO will do for us, and all the outputs will be preserved over here. Okay, we'll be able to see the outputs even in the you can say print output format right over here, right? Now, once this is done, let me close this async function. And okay, I think all good till now, right? People are following up till this point. Any questions till this point? No, I believe. All right. So let us now look at the next part of this program, which will be right over here, agent-based selection of best email. Okay. So what we will do is we will create a one function known as select best email. What does this function do? It demonstrates an agent which can pick the best email from a set of options generated by other agents. So by now, if you realize, we have three agents declared in our code which write emails. Now we are going to write and declare a fourth agent which acts like a judge. Okay, it's like a jury or the final decision maker, which will read the emails from all three people and select the best email which this person thinks or which this agent thinks is useful for the potential sales call. Okay, so see, sales speaker is a variable name which I'm giving to this part. It is an agent which whose name is sales speaker, and instruction is what? You pick the best cold sales email from the given options. Imagine you are a customer and pick the one you are most likely to respond to. Do not give an explanation. Rely with the selected email only. Just need to select the email. That's all you do. Let me give you some actual insights. If this was a real, actually this is a very good uh, program. This is a very good project. It could be really a good project. But if it was supposed, say, in reality we were doing it, we would design something little more better. What we will do is, see, we will have three different agents, three, four, five different agents to write email. That is fine. But the sales speaker, what it will do is, I'll create one more agent which will try to find on the internet. It will use function calling. It will use a tool to search internet for websites for the client that I'm targeting. Suppose if I'm targeting a Dabur is a product, or say I'm targeting say Lenovo. I'm targeting Lenovo as a uh, client. Okay, so I'll try to find on Google if Lenovo has a website. I'll see lenovo.com. Okay, and then I will also create one more agent that will find the CEO of Lenovo. I'll find one more agent which will find what Lenovo is all about. I'll create one more agent which will find me certain news about Lenovo, which is useful to me. Okay, and by gathering all this information, I will pass this information in this instruction right over here. Whatever writing, I will say, see, this is the company. In the curly brackets, I will put in that variable with like the description of the company. I am creating this product which can be used by this company. We will give certain use cases, certain news articles, the name of the CEO, and we will make this agent understand that based on these conditions, which email do you think we should send? So it will make more precise, more accurate call. That maybe it requires witty call, it requires more concise call, or things like that, right? We can also declare another sale picker agent that can combine features of other three agents. We will be doing this, in fact, in this code. I'll show you how we are doing it. Because this agent is picking the best email from other three agents together, right? So that's the idea. select best email. What it's doing, it's declaring one of this agent, and I give you an example that how you could use more tool callings and make this sales agent more robust, है ना? Because suppose if I have to talk to say Dipanshu, or if I have to talk to Soham, so if I know some things personal about them, then I can start conversation more engaging. That will be more interesting. So for an example, suppose if someone knows few things about me and they directly hit that in the email, I am glued to that email. I'll read that email with more interest. So we can make our agents more engaging like that. Okay, we can try to find information about the person that we are trying to mail over the internet by using a function, a web scraping function. Okay, and more like a rag agent, right? Yes, someone who extracts something like that, right? It uses a knowledge base to understand about the agent and about the person, and then picks the email. But for now, it is simple. We are telling it to simply pick the best email as per their choice. Complete autonomous control given to this agent. We will not ask you why did you pick it. We do not need an explanation. Simply select the best email that you think is useful right over here, right? And what is the message? Write a cold email. What are we doing? We are running uh, again the same method, ditto method, which we explained you on top. But right over here, if you remember, I'll go in fact to the previous function. You will realize we were just printing the best emails over here. That's it. That's what we were doing. But rather than printing, we have outputs right over here. Now we are passing it in the emails, and before we close it, we are passing another runner.run, which is sales speaker, and to the sales speaker agent we are giving all these three emails, and we are only getting the best of it, right? So best email selected by our agent is something that we'll have over here, right? So that's the idea. But if you realize, we have declared our agent, fair enough, that's done. But now we need to give our agent the control to in fact store this email locally. Okay, so let's try to do that. I'll just quickly show you the final part of this code where we will also use tool calling now. So if you remember, part 3 was running agents in parallel. Part 4 was running these agents in parallels, combining it with a final best email picker agent. Okay. So now we have a combination of 4 different agents working together. Okay. All right. So with that being said, all right, let me close everything over here. Okay. Now we have a demonstrator manager agent and things like that. See, we are simply running a sales manager agent with tools. So what is this function all about? See, I'm breaking these functions into step by step learning. In the very first step, which is part number 3, I only explained you how you can use async IO to run different agents together. Okay, and outputs is nothing but the output of all these three agents. In the part 4, what I explained you is that I declared first one agent which will act like a sales speaker, and everything is same from the previous function only. Write a cold email, then async IO gather this output. This complete selection what I have done for you is from the previous function only. But right now, I'm just showing you now we can use one more agent and get the best email. In function number 5 or part number 5, everything is same. See, we have the same results coming in, the same outputs coming in. Okay, I'm again declaring a sales speaker. Okay, and then I'm again giving it that, and I'm getting the best email result. Everything is very much similar to the previous functions. Now, what is changing here? Now I am declaring one more agent. Now we will create a final manager agent that has tools to save the file. Okay, this is the only difference. In fact, if I delete this much of the code from line number 82 to 139, it is not useful to me. But to teach you one piece at a time, I have created different functions. Okay, we can also declare another step sales speaker agent that can combine features of yeah. Okay, this is done. Why are we using await? Okay, so if remember I told you that asynchronous programming is doing what? It is hitting all these three calls in parallel. Okay, but at the end we have to use await to make sure that all the functions have finished running before we go to the next step. Okay, so await is used to make sure that if any of the executed command or executed thread is still not completed, because after this line, after line number 170, we will need outputs of all three things. So we cannot wait till this point. Okay, so see, on line number 153, we run this three things in parallel, and without worrying for the output, we can create an array right over here. We can declare a sales speaker agent, and we can do this task. But now we will have to await before we get the output from all these three things. Okay, so that's where, because after this we will need the best email and further things over here, right? So till here we have learned that we can pick the best email. Now we are doing what? So now we are creating a final manager. What is final manager? So you have received the best email. Your task is to use the save email tool. Okay, this is how we will declare the tool to save the email body to a file. The email body is provided as your input. Okay, and in the tools, you remember how the format is. Tools, you have to pass it as an array. You can declare your model, and with it, uh, okay. So I'll not need trace. I'll just simply delete this part of the code. Okay, and I'll say result right over here. Result equals to await runner.run final manager with the best body. Okay, so final manager will now be able to use my tool which I declared on the top to save the file locally. And once it is done, we will have agents final response and agents run complete, and we will have our email generated. So that's about the complete program. And when I give you this file tomorrow, remember students that part number 5 is the complete code from line number 143 to line number 190. Uh, do not get confused, because part number 4 and part number 3 are just snippets of part number 5 to explain different tasks. Okay, so this is where the complete code is, and it is very simple and straightforward right over here. Only last thing is, now we need to execute the main block. Okay, so if name equals to main thread, so we will just put that right over here. Okay, I'll run the very first run parallel agent. I'll comment this two part. Okay, I'll save it, control S click, and let me try to run Python agent openai.py. And if you remember, I'm running asynchronously run parallel agents method. What does run parallel agent methods does? It runs three agents parallelly and just prints the output for us. Okay. So if you see, generating parallel email is printed on the terminal, which means our execution has started. It is using Llama 8 billion 3.1 model locally to do this. Result is coming in okay. So okay, we have the output. In fact, the best way to use asynchronous programming is not with the await, because it might feel that, what is the benefit of using parallel programming when we are using await. So it is, asynchronous is more useful when we can do different tasks, but before using the await. So we'll skip how asynchronous is using. Okay, my voice is breaking. Let me once cross check the internet. All right, so we have the agent one output. Here's a sample cold sales email. Subject: optimize your compliance posture with compliance AI. Dear receptionist, as a business leader, you're likely away, and this is the email written over here. This is professional. We can see warm regards and things over here, right? Whereas we have agent output 2. Subject: your company's secret shame. You see, this is a witty, and this is a witty type of an email that we have. Conqueror of meetings and master of Excel formula. As a fellow business owner, I am guessing you have had to navigate the treacherous waters of audits and compliance at some point, and if you haven't, consider temporary reply. You see how witty this email is. Rather than doing a professional way of thanks and regards, it is cheers with an exclamation mark. And if you look at output 3, such a precise small output right over here, right? As a cloud service provider, you know how important it is to meet stringent security compliance things. We can help you with it. These are the features that we can give you. Say goodbye to tedious documentations. Ready to experience our surveys best, and so and so. Okay, so this is the idea around using three different agents. But now I want to run the select the best email agent. In fact, let me just clear my output once from this file. I'll show you how select best email works, which is our another method which uses the final agent to make the email select the best email. Okay, so running a sales speaker agent to choose the best email, and this is the best email chosen. Uh, for now, I didn't have print statement in between to show you what those three emails were, but we have the direct output of what the best email is. And just by looking at it, I can definitely tell you that uh, this email is from the VT agent. Anyways, that's all around it. I think this was the idea of what agents are all about, and this was our goal for today. Okay, let me just go back. I'll stop my screen sharing. Is the mail sent to the person now? Yes, the mail is definitely sent if you use the third function. Okay, if you use the third function, it will store the file locally. Let me quickly reshare my screen. I'll also show you the third method if you want that. Okay, I'll bring up my screen once again. Can you reshare my screen? Let me reshare my screen. Okay, I think my screen is visible to you all now, right? Cool. Okay. Let me uncomment this. Let me do clear. Let me run this. So it will also depend upon. Okay, wait. I didn't save the file. Control C, clear, save, and run this again. It also depends upon the capability of the agents. So what I realized is that I was using Llama 3.18 billion. Sometimes it was able to send the email agents tool, generating emails from different agents, using a picker agent to select the best email, using the final manager to use our tool, and the tool is called and the email is saved. In fact, you can see there's an output coming right in this text file, right? So we have actually finally able to store the email in a text format. Okay, so this is how you can use the complete idea of using an agent to do an end-to-end task. Okay, agent is something that takes up an input and do a complete end-to-end task completion. Okay, it's not just a large language model. It is more than that. So I hope this idea was clear and we are able to generate the output over here. In reality, we would have hit some API to complete this output. Okay, so yeah, any doubts for this? Are we good to go? Is this email sent to the person? Yes, at the end, if you see, my function was to save it into a local file, but the goal of the function was to actually send that email to the person. So yes, in a sense, this email has been sent to the person. All right. In case of no doubt, thank you so much for joining in. Looking forward to connect with you tomorrow to do more about agents. Okay, we will be seeing how guardrails can help us. Maybe do hands off. Okay, things like that. All right. Yeah. Source code, Jane. Come back tomorrow. Tomorrow I'll give you source code. Bye and thank you all of you.